Hello, we are going to talk about how different types of graphs are used for different purposes. And we'll make a little chart this week. Hopefully, we'll have time to make a little chart that shows you the different uses of graphs. I like to make a little cheat sheet so that when you're making a graph, if you're ever making a graph, you know the right kind of graph to use for the right job. So we're going to look at, we're just using regular paper because we're being asked some questions. And so we're just going to answer the questions. I don't think it asks us to make any graphs. We're just going to choose which kind of graphs we would use. So we're just going to use white paper for that to make it a little bit easier and to not waste our precious graph paper. All right, so I'm going to fold 3 hamburgers, right? And I'm going to go ahead and put my lines on my paper. Same thing on the back side. Okay, so we're doing today for our assignment, just pull this out a little bit. We're looking at pages 166. So I'm going to write my name at the corner, and we're at lesson 4.3. This is a long lesson all about graphing, and it's a doozy. So we're on pages 165, and there's a lot of graphs. Don't panic and think that, oh my gosh, we're doing 800 pages of math. There's like a lot of pages that just have graphs on them. And so we're going to be starting out on number 16, 17, and 18. Okay, so we're going to do 16, 17, 18. And then it's going to say, let's practice. And we're going to do 1, 2, 3, 4, flipping over, 5, 6, 7, and I think that's it on 169 because then the chapter ends. Can't go any further than that. So let's look at number 16. Let's actually look, we're going to go back through and look at some of these graphs and tables and charts. So remember, this is a picture graph, right? And we said with picture graphs, we always want to look at the key, right? So the key is down here. Each star represents 3 visitors. This is the best month to visit a nature park: March, April, May, June, July, August. Probably don't want to visit a nature park in the winter because a lot of animals are gone in the winter, right? They hibernate or they migrate. So Joe then surveyed 48 visitors to find out the best month to visit the park. He used a picture graph to show results. This little girl always has smart things to say. They use her a lot in the book. A picture graph is useful for showing data with numbers that are multiples of a certain number. In a picture graph, we use a key instead of a scale, right? A scale on the graph is at the side. It's the side numbers, right? That's called the scale. If you're using a picture graph, you were using multiples, right? Each one of these is 3, 6, 9, 3, 6, 9, 12, right? And so on. So we're using multiples when we use a picture graph. 15 visitors chose April as the best month to visit the nature park, right? You can see with all the stars. The same number of visitors chose March and July as the best month to visit the nature park. So here's March, here's July. Now, these two peeps are probably saying something very wise as well. I haven't seen him too much before, but I've seen her before. Both bar graphs and picture graphs are useful for comparing data. Okay, so that's important for you to know. We use a bar graph and we use a picture graph when we're comparing groups of data, right? So that's when those get used. A picture graph is more suitable for showing data with smaller numbers, while a bar graph is useful for showing data with small as well as large numbers, right? So you don't want to do make a picture graph with something that has a large amount of data. I told you my class always makes a raisin box graph, and we make the key on the raisin box graph has to be really high. Like we have to say each raisin box represents 50 raisins. So our data is a little bit high to make the picture graph. So usually lower numbers are better when you're making a picture graph. In a picture graph, it's hard to show numbers that are not exact multiples of a certain number. In a bar graph, we can show any number if we choose an appropriate scale. So if we choose a scale on the side that's appropriate, we can use any number we want on our bar graph. So generally, a bar graph is for larger amounts of data, and a picture graph is for smaller amounts of data. All right. Joe used a line graph to show how the temperature at the park changed over a few hours. And that's because a line graph is used for showing how data changes over time, right? Unlike that weird wire graph that we did in the last lesson I filmed for you, that showed no change over time. Mostly line graphs showed change over time. And that word is used in every math book I've ever seen. Line graphs show data changes over time. All right. So this is a temperature change at the nature park, from 9 in the morning until 6 at night. The highest temperature was recorded at the park at 2 p.m., right? You can see that's where the highest data plot is. The temperature at the park increased from 9 to 2. So from roughly about 9 to 2 o'clock, the temperature increases, and then it starts getting cooler in the afternoon, right? And then it decreased. Okay, so we're going to choose the correct graph to use for the correct data. So on number 16, our choices are we can use a bar graph, we can use a line graph, or we can use a picture graph. And we're going to explain our choice. We're going to do a comparison. Ooh, that automatically means bar graph or picture graph. So no line graphs. A comparison of the number of visitors to an art museum in 6 different months. You tell me if this data is too small or too large. These are number of visitors, 230, 80, 340. I think this sounds like a bar graph. I think if you had a key, you would have to have a really funky monkey key that would say, each little picture of a person represents 100 people, right? And that would be hard because of this one in February. So this has a lot of data, especially April has a lot of people. So does June. So that to me tells me that while there's going to be a lot of data, I don't want to cut out little pictures of people or draw them in on my graph. I'm just going to use a bar graph. So we would say bar graph. And let's give our reasons. Number 1, we have comparison. It said we're comparing. When you do a comparison, you use a bar graph or a picture graph. So that told us we're also not using a picture graph because we have a high number of data. Right, so we have like 630 people, 540 people. That's going to be really hard to make a picture graph. It's just a little extreme. Okay, let's look at 17. We still have the same 3 choices. Number of books read by some students each month. I see a time word right there. Month, 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 month. Student, Andy, Brian, Doug, and Candy. And number of students, or number of books, 12, 8, 16. Candy's only reading 4. I think they're stereotyping the girl in that group, saying she's not reading as much. So, a blank can be used when the numbers are small and they're multiples of a certain number. So, this is over time, but we're actually comparing it. At first I thought, oh, let's use the line graph, but they're also comparing 4 people, right? So they're making a comparison between these 4 people, and we don't really have any data relating to time on here. So like, even though it says month, and that's a time where none of our data relates to time. So I would say picture graph. And I would say that because we're comparing people. We're comparing readers. Right? And the numbers are small. The data is small. And also the data is in multiples of 4. So it would be really easy to make a key, right? Because our data is Andy 12, Brian 8, Doug 16, and Candy 4. So we could make each little picture of we could make pictures of books, and each book would be worth 4. And Candy would have 1 book by her name, Doug would have 4 books by his name, Brian would have 2 books by his name, and Andy would have 3 books by his name. Does that make sense? Okay, let's look at the next one. Pete's weight over 5 months. I'm seeing a time word there, so I'm suspicious that it might be a line graph. So we have January, February, March, April, May. This is his weight. It's going up and down. And I'm going to show that. I'm probably going to use a line graph because it shows change over time. So it shows change over time. We're also not comparing groups. We're talking about Pete's weight, and it has nothing to do with like other students or groups of people or classmates, right? So I'm going to put on here only one person. So we can't really compare with groups because it's only Pete, right? There's only one person to discuss. Okay, so let's look at our next problem. Say, let's practice, complete, use data from the line graph. So this looks like a kind of a science fair. Science fair uses line graphs a lot because sometimes you measure things by speed when you're doing science projects. The line graph shows the height of a balloon above the ground between 1 p.m. and 6 p.m. on Monday. So the balloon went up, and then at about 4 o'clock, it started going down. And then it started going down fast, right? As it lost its the gas that was in the balloon. So number 1 says, what was the height of the balloon at 1 p.m.? 40. And height of the balloon is in meters, so 40 meters. So 1A is going to be 40 meters. 1B at 5 p.m. At 5 p.m. it looks like it is, so here's 5 p.m. we go up. It looks like it's halfway between 50 and 55. And so halfway would probably be 52. So we're going to say 52 meters. And if you wanted to be really picky, halfway is going to be 52.5. Right? Because if it's exactly halfway, it would be 52.5 between 50 and 55. So if we're being super precise, we can do the decimal thing and say 52.5, 52.5. Okay, let's look at number 2. What was the greatest height the balloon reached? At what time did it reach this height? So the balloon at its highest point at 4 o'clock was at 55 meters. So we're going to say at 4 p.m. it reached 55 meters. In which 1 hour interval did the greatest decrease in height occur? Well, that's down here at the end, right? When it starts going down, it's only going down half of this space, right? And then it really starts going down. It goes down 1 whole and a half. So from 5 to 6 p.m., we could say that's the greatest decrease in height. From 5 to 6 p.m. was the greatest decrease. Okay, let's look at number 4. What was the difference between the greatest and lowest heights reached by the balloon? Well, so we're going to take the lowest and we're going to subtract it from the greatest because we saw the word difference. So this is 40. 40 is when it was the lowest, the least, and 55 was the greatest. So 55 minus 40 is going to be our answer. And if we take 55 minus 40, we're going to get 15 meters, right? Was the greatest increase. Okay. Now we're going to look on the next page, and further on the next page, and we're going to have to make some decisions about what kind of graph to use. So remember, bar graphs compare data, line graphs show data over time, and picture graphs compare data, but they have to be in like manageable small chunks, right? If there's too much data, it's hard to do all the little pictures. It's hard to have room to show all the pictures if you have a lot of data. So we're going to choose the graph to display the data. We're going to write bar graph, line graph, or picture graph, and we're going to explain our choice. Mrs. Tucker. This is a long story. Here we go. I'll make you read it with me. Mrs. Tucker, the school librarian, has to make a presentation to the principal. She collected these sets of data. Can you help her to select the most suitable graph for each data set? Mrs. Tucker wants the principal to see the difference in the number of visitors to the library in the first few weeks of the year. So here we have week 1, week 2, week 3, week 4, week 5, week 6. And this is showing number of visitors, 300. That's a lot. I'm seeing big numbers, which means I'm saying no on the picture graph, right? 300 people, 180, 260, 340, 420, 150. Those are big numbers. So I would say ixnay on the Ixure graph pay. Ixure pay F gray. So are we showing change over time? Yes. So I would think that we would probably use a line graph because we're not comparing groups of people to each other. We're showing change over time. It's happening over 6 weeks, right? So let's put on their line graph. This is kind of fun. It's like being Sherlock Holmes, only with math. You're the Sherlock Holmes of graphs. So we're saying it's a line graph because it's showing change over time. And also we can't say too much data for a picture graph. We could also say, excuse me, that we're not comparing any groups of people. It's just visitors to the library. We're not saying boys visiting the library, girls visiting the library. So we're saying no comparisons of groups. Okay, let's look at number 6. Mrs. Tucker asked 30 grade 1 students their favorite choice of books so that she could plan the Young Readers program. That sounds like fun. So, are we comparing we're comparing different kinds of books, right? There's no time aspect of this. Nothing is happening over time. So that eliminates line graph. We have adventure, sci-fi, mystery, fairy tales. We have, ooh, look at all these. I'm seeing multiples of 3, right? 6, 3. So you could make little pictures of books. And you could have each book would be worth 3. Science fiction would have 1. Adventure would have 2 books. Mystery would have 2 books. Fairy tales would have 3 books. So that seems ripe for a picture graph. Picture graph, right? So let's say picture graph. No change over time. So we know it's not a line graph because there's no time related aspect to it. And we have convenient small data in multiples. Like it's just too good to be true because we have 6 and 3 and 6 and 15, right? And we are comparing groups, right? So we're going to do comparison of book types. So that's like comparing a group, right? Okay, let's look at the last one and then we're done. By the way, I got to see you guys today. I'm filming this on Friday. It was lovely seeing so many of you. Just fantastic seeing you in person. It made my day. I'm going to get weepy telling you this, but seeing you in person makes me so happy. I mean, I love seeing you online, but seeing your actual face, your cute little faces, and talking to your parents, it was just a delight. So thank you if you stopped by to pick up your work. I really appreciated seeing you. It was a delight. All right. And it was a delight seeing all pets that came with and siblings. All right, number of students at the library. We're looking at time. In fact, we even see time on the table, right? Number of students 9, 11, 11, or 1, 3, right? We're not comparing specific students here. It just says like a whole bunch of students. It's not boys versus girls. There's no like groups of students or, like grade levels, like first graders, second graders, because that's bar graph material right there. This is showing change over time, right? And as far as the amounts of data go, it kind of is in multiples. Well, sort of. 28 and 35 are 7, multiples of 7, but the other 2 aren't. So I would guess just because, number 1, they're even throwing this softball at you, they're calling it time, that's going to be a line graph. So we're going to say line graph, and we're going to say there is change over time. And there is, I would say it has small data, but it's not in multiples. Small data, no comparisons, right? The key, whenever you see things being compared, that automatically rings a little bell in my head that says bar graph. And if you're not seeing comparisons, then you are kind of, you're sent in line graph territory, right? Okay, I hope this helped you. Also, we will make a little graphic organizer to talk about the different kinds of graphs that we use. I will put that on our schedule because I always find that it's helpful to do that for kids so that they can tell. Um, every now and again, you'll see a graph and you'll think, I'll see a graph and I'll think, they shouldn't have used that particular graph for that. Science fair, all the time, I walk through science fair and I look at people's boards and I think, should have used a line graph, should have used a line graph, or should have used a bar graph. Because younger kids don't really know when you're a first grader or kindergartner or second grader or even third graders, sometimes you aren't sure what kind of graph to use. Most of the time, when you see older students, science fair boards, they're spot on because they know the difference. Um, or sometimes you can even like look in your math book, like that weird wire measuring graph. Shouldn't use a line graph on that one. So hopefully, we'll make a little chart, a little planner, and that will help you to know which kind of graph you should be using. Okay, I hope this helped you. And again, it was great seeing some of you, and I wished I could see all of you. Um, one day we'll all be together and we'll have a giant birthday bash for everybody. All right, thanks so much.